Okay, guys, we can now start another chapter. This chapter is on data structures, the types of structures you will be using in your implementations, in the algorithms. And so it's better you understand the fundamentals of different types and use them in your projects properly. So what are types of data structures we have? We have stacks, queues, DAGs, lists. We will cover all this linear type of data structures, and then have some examples in Python by using the Python list data structure, how we are going to implement these special data structures using the built-in data structure of Python. So don't you see the slides and you have problems? Okay, no problem, then I'm continuing. And what we're going to do in this chapter, we'll make use of some examples to understand the fundamentals. We will have nice examples. The first, what are the linear data structures? The ones actually I mentioned a moment ago are all examples of linear data structures. Stacks, queues, DAGs, lists are all linear data structures. And they are ordered according to when they are added or when they are removed. They are kind of linear structures. You sometimes add items into these data structures from the top, or sometimes add values to the bottom of the data structures. We will discuss the types of them, but they are all linear. And can you give an example to a non-linear data structure? The trees are actually kind of non-linear data structures. So since you can add any value, any node to different levels of the trees. And in the linear structures, things are much simpler. We just have two ends. Sometimes we call it as left or right, sometimes front and rear, and sometimes top and bottom, but it doesn't matter. They're all linear and have just two ends. So now let's first focus on the stacks. This is one of the fundamental type of data structure, and it's again ordered data structure. And the thing is that assume that this is a stack, and if you are adding new items into that stack, you will be always adding the new items from the top. And once you want to remove anything, you can only remove it from the top. You add to the top of the data structure, you remove item from the top data structure. So the base is quite important, the base of the data structure, since it's quite difficult to reach to the base. So it's better you put the least important ones, least important values into the base, and the ones actually you are playing more should always be at the top region of your stack. We can easily say that this data structure kind of having last in, first out. Since we are only using the top part, once you put an item to the top side, then if you want to remove anything, the one at the top of the data structure should be removed first. So we can say that last in, first out. There's another representation. Newer items will always be at the top, as I mentioned, but the older ones, the ones you are not using too much, will always be close to the base of your data structure. So there are some examples in our real life. If you consider trays in cafeteria or stack of, let's say, plates at home, they are kind of stacks. Another example is the stack of books or notebooks, as you see. If I add one more book, it will be one more notebook. It will always be at the top. And if I want to remove one of them, I need to remove the topmost notebook from this stack of notebooks. Another thing is web surfing. For instance, if you continue clicking some links, and then once you go back, you will always come back to the item which is actually on the top of the stack. So in the history of your web browser, we have a stack data structure, and the topmost value is always the website which you have visited the last. And where can we use these stack data structures? We can easily use them to reverse the order of items. Let's consider this one. I have red notebook. If I remove it, put it somewhere, remove the brown one, remove the yellow one, and put it on top of the brown one. So if you simply remove and add these items into another stack, you will be doing a kind of reversing operation. Let me repeat it. I removed green one, put it at the base of another stack, remove the brown one, put it on top of the green one, and remove the last notebook from the initial stack and put it on top of the new stack. Now you see that it's the reverse of the original stack. This is how it's actually working. We have 4 items, as you see. This is the initial operation. We first put 4, then dog, then true value, then 8.4 value. This is the initial form of our stack. But once you remove them, 8.4 will be the first item, and true will be the second, dog will be the third, and lastly, the fourth will be the fourth item in our, let's say, new stack or our set of operations. Any questions, guys, about the fundamentals of stacks, stack data structure? So let me briefly start discussing the stack operation. What can we do actually with this fundamental stack data structures? So these are actually the methods we will be using in a kind of a Python implementation. This first function is used to construct the stack data structure. And with push item, what we do, we are adding a new item into the stack. I think it's better I use. So in the first function, we are building an empty stack, which has a single slot. In the push item, we put some values into the stack, and you may do it, let's say, 2 times, 3 times, and you may have another one on top. Let's say this is N2. You may have another push item comment. This will be N3. And then with pop, what we do, if you, for instance, pop an item from this stack, we will always pop the last one. So the result will be N3. This is an important issue of pop operation in the stack data structure. Once you write simply pop, it will always remove the topmost item from the stack data structure. What about pick? It's somehow similar to the pop item. It will give you the topmost. It's not removing the item, but will return you the value of topmost item. isEmpty is a very simple one. Once you call this function, it will tell you whether the given stack is empty or it has some values. And the last one is again an easier one. Once you check the size of your stack, it will simply return you the number of items you have in your stack. Here is an example. And on the leftmost column, we have the stack operations. At the center, we have the content of our stack. And on the right-hand side, you'll see the returned values. So at the beginning of this operation, assume that you have a stack which is named as S. And S is right now, obviously, since we didn't add any items, it's empty. So we are checking whether this one is empty, and the computer or our implementation will result in a true value. Yes, it's an empty stack. And you see that the true values here, since it's empty, but with the second statement, what are we doing? We are putting an item into the stack, which is 4. So now, as you see, the stack content is changed. We have a value here of 4 here. It's not returning any value since this is just putting a value inside the stack. It's another push operation. We are pushing a string, a doc word, let's say, into the stack. And as you see that, doc is right now the topmost item. So once you call the peek function, it will return the value of the topmost item, which is doc here. And that fifth operation, we have another push method. It's pushing the value of true into the stack. And as you see, true will be at the topmost part of our stack data structure. So once you check the size of it, obviously it will give us a value of 3 since there are 3 items. And once you do a check whether it's an empty or a full, let's say, stack data structure, this will obviously give a false output since we have items inside the stack. And the rest is similar. If you look at the pop item here, we said that pop is used to remove items from the stack data structure. And it will always remove the topmost item. So initially this was the content of our stack. Once you pop an item, it will output obviously 8.4 and the size of our stack will be decreased to 3. Another pop operation, the true value is popped. We have 2 items remaining, so if you simply check the size, it will return you a 2 value.